Welcome. I've got quite a lot of new faces I've not seen before. This is the introductory talk from WiredSoc, so if you actually have some computer science experience, it could well not be that technical, but this is the first talk of many, so it's just an introduction to see how many people we've got coming. Next week we have somebody from ITS to come and talk, and then after that we have, 2 weeks, we'll get the next session, yes. And then we have people from Apple and Sun coming to do demonstrations of their new technology. So this is just a warm-up. Yes.
Apple and Sun bringing free stuff.
Apple and Sun do claim to be bringing free stuff, yes. Yeah. So I tried to get if it was going to be a Sun Pen or Sun Fire server. He said, stop being cheeky and hung up basically with the report.
Ask for Sun t-shirts instead.
Well, I have to pay for this tab, so free tab. Okay, I am Jonathan Ward. I'm the Communications Officer from WiredSoc. And this talk will be an introduction to the ideas of being a systems administrator and how to use a Unix-based system. Next slide.
It's on.
Ah, exciting. This is a nice diagram I found on the internet picture. It made me laugh. But this is the first part of the talk. It will be about systems administration. You can read that if you really want to. It made me chuckle. Okay, next slide. Or does anybody really want to read that? That's not.
No.
Alright, next slide. And again. Alright, what does sysadmin actually do? What are the roles of a systems administrator? Alright, I'll let you get involved in this. Anybody, what does sysadmin do? Not you.
Screw up.
Go. Okay, in our case, systems administrators screw up quite a lot. Anybody else, what does systems administrators generally do?
Function of root,
Sorry?
like a root.
Yeah, they generally systems administrators have the root account.
Yeah.
But what do they do with the root account? What's the responsibility of being a systems administrator?
Maintenance.
Maintenance, yes. They maintain the server, so yeah, definitely. Next slide. Yeah, they basically administer the system, they maintain it and ensure that it is doing what it's supposed to be doing. A system administrator can admin between one single box and an entire farm of servers with many thousands of machines running on it. It's similar work, but it just scales depending upon the size. Okay. Okay, there's types of administrator. This is by no means an extensive list, but outside the real world there's many different types of jobs you can get. A network admin or security admin. Security admin is quite interesting job. Or a database admin, DBA, or web admin, all involving different fields. Typically in a big business you wouldn't have one admin doing everything. Maybe in a smaller business there would be a one-man does all, but typically in the real world you're going to have teams of people doing these jobs and more. Okay? Well. Okay, any monkey can really run a server, you can run a server. Sorry? Spell checking. Okay, few people can do it well. You can run a server from under your bed on an old 486 machine if you really want to. But if you take that machine and then put it in part of a massive scaled network and you send 200,000 HTTP requests in it, it's going to topple over quite fast. So there's keys to actually maintaining a good installation and making sure that your network doesn't cry and explode every so often as ours may do. Okay, getting the system actually up and running is easy. You can stick a Debian or Gentoo disk if you're insane into a server and get it up and running in, say, 20 minutes. But that's when the work gets hard after that. It's keeping it running. So to keep it operational, keep it doing stuff. So if you've got a web server, keeping it serving web pages under high stress. If you've got an NFS server, keeping it exporting.
Oh,
It's always one.
certainly.
Would you like to take a seat? Thank you. That's our Vice President. Okay, I'll take a go. Okay, some things on a server are common sense. It doesn't need to be all ridiculously technical. Keep it simple, don't try and do ridiculously complex things. Okay, so next will be some ideas for running a system. Not technical, but some cases common sense. Okay? Okay, you need to keep your system stable. If it's not stable, you're going to have major problems. If you're in a bank, for instance, and you have 200,000 users, and your banking server goes down every 2 days, that's, say, hundreds of thousands of customers that have just lost access to an account, and you're going to lose your job quite fast. So there's things that you can do to ensure that the system is going to be stable. For example, you install try and testing software. If you've got a system, a production system, a system that's not backup or reserve system, one that's constantly doing a job, you want it to be running software that you can ensure and guarantee is software that isn't going to topple over every so often. So you wouldn't install beta software, you would install alpha software, you would install tested software. For instance, companies have policies whereby if they're running Windows, they don't install Windows updates until a week after they've released, because there could be potential problems with those updates that could cause the system to become unstable. So there's a staggering between software being released and adoption of it. For example, recently the Royal Bank of Scotland completed what they called the NT to XP project, which was last year they only upgraded to XP, because after that time they felt that XP had become sufficiently stable, and they're definitely not moving to Vista at the moment, or certainly for a very long time. Okay, okay. Second is hardware failure. Hardware failure is an unfortunate thing that you can't really avoid as a systems administrator. You can have hard disks failing you can have power supplies burn out. Any part of the system can effectively go wrong, so you want to protect against it to ensure that your system doesn't go down. Okay, things that you can do if you've got backups aren't really a protection against hardware failure, because backups themselves are on hardware and they can fail. But if you have important sensitive data that you want kept, you back it up and prevent mass failure when you lose important data. I've got RCR from Melville, and I get people who complain to me that they've just lost their essay running it off a flash disk that they put through the wash. So, keep a backup somewhere and it'll ensure against failure. On the power supply front, if you've got a place which is known to have power shortages or power outs, you probably shouldn't have a farm there in the first place. But you want to prevent against it. So typically you have a massive server farm right next to a power station. But if you don't have the luxury of being Google, you can have large amounts of backup and redundancy. Like BT in Edinburgh, quite a few of their telephone exchanges have large diesel generators outside, so that if things go down, they can keep the diesel generators churning and keep everything working. Okay? It usually supports hardware, and if you're going to run an amazing cutting-edge server, don't use a network card that you just found at the bottom of a bargain bin in Macklin. It sounds funny, people do it. It's a bad idea. So use proper off-the-shelf kit, or off-the-shelf cell kit, that works. And importantly, no dirty hacks. don't string things together using netcat, grep, LA, or use LS, I don't know about that. Or just string together some really dirty Perl script that results in things working, but working in a way that makes people's heads hurt. Okay, go for the next slide. Okay, scalability. Having a system expand with demand. Almost right. If you've got a small scale network, so say you've got a small company, you've got 5 servers, and you're about to be bought over by a major company, so you need to, or you're merging, whatever, you want to expand your network quite drastically. Now, if you 5 servers are very old and antiquated things running on old legacy application, you're going to have a very hard time keeping up normal operations for your business. So you're wanting to have hardware that's up to date, technology that you can expand very, very rapidly. You want to have documents so that if a sysadmin should leave, the new sysadmin can take up the slack, read all the documents, be up to speed on the system. I see a cringe face there, because apparently that not happening can cause problems. So yeah, document everything, comments and config files, documents to staff members saying what's happening, so it's a good idea. Okay, design everything in expansion in mind, unless obviously the system's never going to expand, it's a test box that you can leave in a cupboard somewhere. But don't write software and don't deploy software with a very narrow, insular idea, because when it comes to expanding, even if you didn't anticipate it first of all, you can have difficulty. Okay? And as against the standard, if you are running a completely in-house developed application which runs the WiredSoc text transfer protocol instead of running HTTP, you're going to have problems when you try to upscale and integrate with other systems. Because everybody else is running Apache and you're running a magical piece of technology that nobody's ever seen before. So if you actually run standard, so if you code everything in XHTML for your intranet pages, and if you code things using proper thought out techniques, you're going to have not much difficulty when you come to expanding. Okay, use applications to meet demand. if you're running a massive SQL server farm, you're wanting to use something that can actually handle the demand. Always think of something expanding. You use SQLite for a small project, and it expands quite suddenly. You're going to find that your database server gets very, very hot and cries a lot. So keep expanding a lot. Yeah, and avoid abandonware. If I'm about to install a server, I'm not going to install Windows 98 of it. That's probably a very, very bad idea. Yeah, you look like you've done that once or twice. Let's move on from that.
Yeah.
He's our chief sysadmin. Anyway, move on. Okay, security. If your system isn't secure, you're in trouble. Especially if you're a business where you have sensitive information. So potentially, if you lose your information, you can get in trouble under legislation like the Data Protection Act for failing to protect your data. So you get in trouble from the government, and that's never a place you want to be in. So if you don't allow physical access to your system, lock them up in a room, have no physical access to them, that means that, first of all, somebody can't smash your window, jump into your building and walk off with a terabyte array of data. It's always a bad case to happen. Okay, don't run old versions of software. If I run Windows 98 on my machine, it probably the ping of death would take it down in about 30 seconds on the internet. So make sure you're running the most up-to-date version. So you're up to date with all updates, and everything is completely up to scratch, because if it's not, it lies the possibility that it's a well-known exploit. Okay? Firewall systems, obviously, there's sometimes where you want to have an open firewall, or something even where you might not want to have any firewall at all, but generally for all outlooking systems you have a firewall installed. Block all ports that aren't in use. Just ensure that nobody can possibly do any damage to you. Okay, keep going. Okay, encrypt all sensitive data. If you're the Ministry of Defence and somebody steals your data, it's quite bad and reaches the front page of the BBC News. And if it's encrypted, you can just go, it's encrypted, there's no problem. But they wouldn't do that. Restrict the user's functionality to require. It's infuriating, I know, when you sit there and go, you don't have access to this file, go away. But it is a necessary evil. Because if I'm in accounting, I don't want, or I shouldn't have access to files from the main project planner, and vice versa. So everybody's restricted to their own small space, and they can't start causing a problem with everybody else. Okay? Okay, enforce a rigorous password policy. If I had my root password as password, for example, that would get hacked quite fast. Even if users should have a mix of, the usual stuff you get on Hotmail. Characters, password, symbols, characters, numbers, etc. Mix them all together and make something that program won't crack in under a minute. Okay? Yeah, perform security audits. Get people to come in, or you can do it yourself, and nmap all your systems, run NASIS on them, check that your machine isn't susceptible to things like ARP spoofing, whatever, and make sure that your network can be easily compromised. Okay? Okay, these are reasons why you should do these things, because a piece of software is not stable. I rush into deploying a piece of software, say a piece of virtualization software onto a server, and after about a month of running it, it becomes unstable because we didn't test it. That means the entire system has to be rebuilt and replaced. So that obviously means downtime for your business and you're in trouble. Okay? Okay, if it's not scalable, it shouldn't really be deployed. So if you're deploying a piece of software that's near its end of life, and 2 years later you come to need to buy 20 more machines and make a cluster or whatever, you have troubles because you can't expand, you can't scale, you need to replace the entire system. Okay? And the system's not secure, it should be deployed, because the system is obviously a version of software. Some script kiddie who's just managed to get some stuff off Milworm has just managed to hack your system, and all your files have just appeared on eBay for the highest bidder, which is never good. Okay? That's basic sys administration. So that's not really an intensive guide to get sent from our console and hacking some stuff, but that's some general ideas. When you go to running a server, go in with these ideas in mind, and you will, in theory, be an excellent sysadmin. Because if you just go in front of a machine and hack away, problems can happen. Keep all these things in mind, and your server will be good. Unix is what we're moving on to now. Oh, how about that slide? It's a nice wee picture. It has all the Unix mascots and pictures of them. Make me happy. Okay, that's it. And what is Unix? Unix is an operating system. Has anybody heard of Unix? Has anybody not heard of Unix? Get out. Unix is an operating system. It was originally designed in the 1970s by the creators of C at Bell Labs in America. It's most of the cells on the internet run Unix. It changes ever so often, but it's more or less all Unix servers that perform most of the internet's backbone. So they're highly developed, highly stable, and are very well respected. Okay, yeah, it was developed in 1969 and the 70s by Bell Labs. There's now hundreds of variations of Unix. Unix is not just a single operating system; it's come to be a brand name for a group of operating systems. Okay. Okay, one Unix system, there's quite a lot of them. Proprietary, if you're in a massive bank, or if you're in a massive company, you're going to encounter these sort of things. AIX, which is IBM's proprietary Unix, HP Unix, which is HP's, Open Servers, which is SCO's, I can't see SCO going for much longer, and Mac OS X. People don't think it is a Unix system, but Mac OS X is very much Unix based, especially the server. That's more so you can run standard Unix applications on Mac OS X. Open source for all the BSD families, originating from the BSD from the 70s. Open Solaris, which is Sun Microsystems offering. We've got Linux, which is what we're going to talk about a bit more. The open source, well known, everybody loves it. And if you learn some skills about Linux, you can more or less translate it into AIX, or if you learn some of NetBSD, it goes to Open Solaris. So if you learn some skills and you need a job, or if you have any community service anywhere in the world, you can always transfer the skills. Okay? Linux. The Linux kernel is the core of the operating system. So technically Linux is a bit of a wrong name, but everybody calls it Linux anyway. This kernel is the core of the operating system developed by Linus Torvalds in the early 90s, was a Finnish student in Helsinki. Okay? And the user space, the actual things that you use as a user, that was developed by the GNU project, Richard Brother Stallman. If you ever know who he is, you'll learn to hate him. He developed the user space tools, and together, yeah, you get GNU/Linux is what it technically should be called. GNU running on top of Linux, but everybody just calls it Linux. There's many distributions, because it's free. Everybody who's technically competent at one point decided, let's make your own version of Linux. So there's own different brand names and tiny differences between major differences. So there's some, has anybody heard of all of these? Yes, I'm assuming you've all heard of them. If you haven't, I'm going to kick you. So Slackwell's Asian has a Debian, Ubuntu, modern spin of Debian, Fedora rose from the ashes of Red Hat, Mandragoora came up with Red Hat, Arch, don't really care about that, Gentoo, Infidel, and down to on SUSE, these are all wonderful things. Sorry? LFS. Linux from scratch is not a distribution. Move on. We use Debian because we love it, and he makes us use it. Move on. Can you be a little more technical? But I don't have a beard, so I can't go too technical. Okay. Hello.
Hi.
Do you want food here? You can go to that classroom.
It's just that my stuff is in
By all means, you may collect your stuff. Okay. You can sit down and watch if you really want. You know what Unix?
That's fine, thank you very much.
You're attracted when I think of Unix. Okay, Unix is designed with the ideas of portability, so you can move software from one machine to the other without having to recompile it all.
Thanks, sorry.
By all means. Time sharing, so it shares CPU time between multiple processes, so you've not got one massive process running, it shares it all among processes, and that allows multi-users to be running, so it's a multiple user system. So inherently it's designed for a server, you can have many people logged on, many people doing something at once. Okay? Mostly programmed in C, it was written along with the people that wrote C, so the two go hand in hand, Unix and C. Okay, everything's a file. Config files are a file, obviously. Devices are files. So your CD drive is represented as a file. Your hard disk is represented as a file. Inter-process communication, so communication between two processes, that's a file. Meaning that as a human, you can understand lots of things about Unix. It's not like Windows with a magical registry in some far-off registry land where it's hard to understand. Okay, keep going. Okay. Do one thing and do it well. It's not really the massive lump approach to software design. Instead of having one application as everything. Unix uses small tools. So if you want to list a directory, use ls. If you want to search your files, you use something called grep. If you want to do different things, lots of wee utilities. So there's not one massive one. And because of all these utilities, what you can do is link them together using types and input and output redirection to make one larger program you see as a smaller program. And that's generally referred to as a Unix philosophy. That's how it's designed in mind. Okay? Okay, what's the black scary thing? Move on. Okay. Oh. So if you log on to a Unix system, especially ours, you won't see a shiny GUI. There will be no Windows desktop, there will be no GNOME or XFCE or that KDE thing. There will be a prompt akin to the DOS prompt of the 90s, but a lot more powerful. There's been a lot of debate over the ages of what's more powerful, GUI or command line interface. You can hack into a terminal very fast, do this, and very powerful, but for the average, technically incompetent user, slightly controversial, it's not really that user friendly. But the sysadmin is generally considered to be pretty technically competent and meant to use one of these terminals to maximum effect. Okay? Okay, Bash, the born again shell, is the most common Linux shell. It's basically a small programming language which you can use to write scripts in and interface with directly in the shell. Okay, move on. It allows users to enter commands, so these things are referring to can be typed in a prompt and run. Okay? Okay? Okay, navigating file system. Okay. So simple commands I was just talking about. For the list files, you use ls at this magical black screen. And when change directory, you'd see and then the directory you want to go to. And then display which directory you're at, pwd, it would say you're in this directory. Okay? And okay, coming in was a slash nonsense. There's not like Windows, there's a C:\\\. Everything's got a nice forward slash as it should be, as per the internet. And it's got a completely different directory file structure. It's not Windows. Now Unix, not Linux, but Unix in general, shares this function. If you look at Mac OS X, if you look at Solaris, if you look at any Unix-like system, there will be this structure. So slash, just a slash, is the root of the file system. That's kind of akin to your C drive. It's the very base of it. It's the lowest or the highest level that you can go to. And that's what everything is contained within. Okay? You've got a /bin, so that's where your binary files are contained. If you have files that run important things, so if things you need to boot up your system are contained in there. Important things like that. Okay? /boot, that's where the bootloader files are. So if you wanted to boot up your system with grub or whatever other bootloader you may feel the need to use, the configuration files most likely are going to be in there, and the binaries possibly. Okay, /dev, as I said, everything's a text file, so the text files representing all the devices are in there. So you'd see /dev/CD-ROM0, and that would be representing the CD-ROM drive. E/dev/HDA0 hard disk, A first hard disk, 0 the first partition on it. Yeah, I know they're not the special files. Yeah, okay, I'm sorry, I don't want interjection to audience. Okay, /etc, which is italicized because it shouldn't be. It contains the configuration files. So the configuration files for your servers, so if you're on a web server, if you're running an FTP server, if you want to change the host name, if you want to change the date, whatever, all the configuration files of your system will be in there in one centralized place. Okay? Home is the equivalent of documents and settings on the machine. That's where all your hardware is kept. Sysլib, that's the libraries like DLLs, but the Unix implementation of DLLs are all kept in there. And that's for the DLLs for bin and sbin. Sbin is disappeared. Mount, that's where you mount a file system. So if you want to mount one of these devices in /dev, to actually access it or read files off it, they'll be mounted in /mnt mount. Okay, /temp, it's where temporary files that like things you download off Firefox while you're browsing are put in temp if you don't save them to your home directory, and then when you restart they'll wipe. There's things you don't really need. Occasionally you can mount temp just RAM because you don't really need it on the hard disk, you just flush it when you're done. Okay? /var, okay. Variable data such as log files, temporary files, email. if you want to temporary file root into /var, it's usually because you want it saved when you reboot. Okay? And sbin, which should be there but isn't, if you go back, or you can stay there if you want, such sbin contains system-wide binaries that are also essential to the system. Okay? Such USR, because you're a user, that made me happy. Such uses a secondary hierarchy. So there would be all these directories you've just seen in /USR. Now that's where all the user-related programs are stored. It's a secondary hierarchy. So within it, it's got another set of bin, sbin, lib, etc. So in USR there's bin, first of all, which contains all the binaries that you need as a normal user. So things that aren't essential to the system, but things that you as a user want to run. So when you're running like a Linux system and you're running GNOME or you're running KDE, all the wee programs that you're running are probably going to be sitting in USR/bin. USR/sbin is non-essential system binaries rather than sort of user-based binaries. So if you're running a server like SSHD, if you run SSHs, that will be sitting in there. All sort of server files, the binaries for the servers will be sitting in there. Lib, that's library for all the user programs, so for bin and sbin, they'll be in there. Local is a tertiary hierarchy from things local to that machine, for things that are specific to that one machine. You could stick another set of bins, sbins, libs, etc. in there. Well, like maybe applications you've developed on your own or whatever, put them in there. In user share, normally you put architecture independent files in there. So things that are dependent upon your x86 box. You put things that you're running at any machine there, and that would be shared in between all the computers on your network if you wanted to. That's the traditional place to put shared files. Okay? Okay, this is the last slide of this section. But if you look, this is the file system as you'd see it. You've got root at the top, and then you've got all things coming off root. It's pretty. I found it in Google Images. It excites me. Okay, would like to move on. Okay, that's enough bored to death with playing around with server concepts. So I'll hand you over to our former chief sysadmin, Kieran. Don't get scared by him. And he will introduce Lighty, which is a web server, and we'll let you have a play around with it. Okay? I'm sorry? I did write the slides, but I expect you to be semi-confident. Okay, you can stand up with me, we can stand up together. Please don't hug me. Okay, would you like to continue? Lighty. Lighty is a web server. It's about the third most common web server running on the internet. It's not IIS, Microsoft server, and Apache are the first two. And then Lighty after that is very good at running CGI scripts very, very fast. And it's quite easy to configure, so that's why I give you a bash at it. It's wonderful, that's not so on Wikipedia. Okay? Okay. Okay, I've been abandoned, fair enough. Kieran will actually do the actual playing of the software. Okay? Ways of installing software on a Debian system like what we use at Ubuntu. There's a program apt, you see I'm not sure. And about apt sounds nicer. Okay, which runs on top of the package, if you really care. And that lets you download software. It's not like Windows where you go into the internet, you download an executable file, you double click on it, you get a pretty graphical install, and you press next, accept this ridiculous license term, yes. And, yeah, but I don't like it. And you just go, there's a massive repository of software on the internet, you type in a command and it gets a file down from this repository, it unpackages it, installs it to your machine, and you just got your software installed. It's one command that does it all for you. It's the preferred way to install software on Debian-based systems.
Why is this?
Sorry?
Why is this?
And why is this? Because it's the correct way of doing things.
And what are the advantages of it?
The advantage of that is that it's tested software that's maintained by developers of your distribution. So it's tested, it's compiled specifically for your system. So you've had somebody do most of the hard work for you. Does that satisfy you?
No, stick with it. Disadvantages?
Disadvantages? Are you just testing me here?
Yeah, well...
Disadvantages of this system include not having a complete repository of software. So if you want some really obscure program that one person in Switzerland wrote 25 years ago, not really highly likely that it's going to be in the repository. So you're not going to get all the software you want, but most of the main package will be there.
Any other disadvantages? packaging software rather than using source distributions?
Yeah, by installing things with packages, your system tends to be slightly slower in theory than running from source where you compile everything manually. Okay, anything else?
Library dependencies.
Dependencies, exactly, yeah. Dependency resolution. So if you've got a package, say, which depends on another thing, which depends on another thing and another thing, apt will resolve it for you. So it'll go get the package that needs this package, this package, this package. Whereas with the source method, you can get into what's called dependency hell, where you have to install something, but you can't install something because you have to install something else before that. And you can't install that because it was either something else. So you get into a situation where you're chewing your hair because there's too many software to install and you can't all do it. Okay? Anybody else like to share that next? Please, by all means. Okay? Source, you compile everything manually, a bit old-fashioned, but in theory you can compile it to be specific to your machine so it runs quicker, or so the Gen 2 components say.
What else do they play?
Sorry?
What else do they play?
I don't know, the police smoke crack most of the time, so I don't know.
They also you get greater customizations that you get to choose options.
Yes, yeah.
Right,
Okay.
so the
Well, we're
package
branching into a
software-
Gen 2 rant, so we're going to stop that now. So if you've got software in your repository, so if you want the Switzerland man software from 25 years ago, you can get it and compile it yourself. Try it. Next slide. Okay, sorcery. If you want to install a piece of software from source, we're going to continue that theme, we'll get a bit more interesting. It comes in an archive of a C file, Unix like C, so it comes with C source files normally, unless you're running something else, Python, Perl, whatever. But in this case it is C. And as per Windows, how it comes in a zip file, Unix uses tar files, which are an archive, and then gzip or bzip, which is a compression tool. So first of all, it's archived using this part, tar, and then it's compressed using either bzip or gzip. And there's also different types of compression program. Get all sorts of craziness like 7-zip and 11-zip and whatever. And you need to extract this to get to the file, so you untar it, you unzip it, other way around, and use tar for that. So it's a small Unix utility, you can untar things, and tar plugs in with gzip and bzip to tar does that part and calls these programs to unzip it as well. So that's part of the Unix philosophy. Okay, and that gets you all your nice C files, so you've got your shiny C files that you want. Okay, so you want to install a program, you've got that nice shiny command prompt, you go /configure after changing the configuration files to your suiting, and that would make all the configuration changes that you specified for that application in a folder, and it will go through a nice stream of text. And then when that's done, you run a command called make, and make would call compiler, so your compiler goes and changes all the C source files into binary so that your machine can understand them. So they're no longer human readable, but you can execute them on your system. So you effectively got the software, it's now runnable. And from that, you're going to make install. Make install will remove these binary files that you just made and all the libraries that are associated that you downloaded from this folder in your home directory, whatever, into the different parts of the system. So the configuration files to /etc, the init scripts to xamsd, the binaries bin, whatever, to remove it all about the place so that everything where it needs to be. Okay? Okay, so we're going to run Lite. So how do we run Lite?
We're going to spell.
We went to spell. That's what,
ITSVD does not have two HTTP.
yeah, it doesn't. But because my spell check and open office is set to finish by default, I didn't notice that. Okay, Lite, it's a plain text configuration file, so you've not got to use some shiny graphical utility. You can open it anything that understands ASCII and change it. What do you need to, before you can run a web server? You need to have the user and the group that the program will run as. Once you set that, you can then tell it to run as that user. You need to have a port which the web server listens to. So especially if you're going to play about with some servers, don't have them all running the same port. Unix does not like that. It says, stop looking at my port, it's my port, it's my port, and they'll fight and cry. And the root of the server, so wherever that your web page is going to be displayed. So if you want to display your personal home files, like /home/ your username, public HTML, that would be the root of your own private web server. But if you want system-wide files, that's one that goes in /www. So wherever you want the base of your website to be, that's what you assign that file to be, or that field to be. Okay? Okay. Unix uses a series of init scripts to initialize services, daemons are something like a server effectively. And these scripts are called startup and shutdown. So when a system turns on, the scripts are run. Be quiet. And these run the program. So they're just small shell scripts. So the commands that you find in the shell, you can write into a script. And instead of you having to type it in, the computer run it for you. And these can run a startup and shutdown to achieve services running that you otherwise won't type in manually. So your system's all up when you turn it on instead of having to manually type out console for ages. Okay. Traditionally on System 5 systems, the one from x/init.d, that's where you put all your scripts, you lock them in there. I know. Okay, and like HTTP, like it can run from an init script. So if you wanted to start up and shut down with your system, you can assign a script in there and do all magic from there. Okay.
Did you guys traditional to have IP addresses saying DB, CC, DB?
I know, but I didn't like that. I'm one for breaking with tradition. And I think address is even spelled wrong there. So yeah, if you go in your web server, you go to the IP address, so 138.251.12, and then 8080 or 8081, whatever you want to assign your web server running on, and then you can check that Lake is running with netstat. Netstat's a program that checks everything that's listening on a port. So netstat's useful for checking what's listening. So if you've not got netstat, if netstat says there is no Lakey, that probably means you've done something bad. And Lakey writes a log to bar log httpd by standard. Lakey. I'm still trying to say that.
Yes, but you should also spell it right.
Shh. And you can change the log is in the config files, but the logs are very useful. So if the server doesn't start due to a bad configuration or due to something bad, you can read the log and understand it, comprehend, adjust, and your server will fix it. Okay. I think the next slide could well be the final one, but okay, go play. Kieran, would you like to tell how to go play?
Yeah.
Okay, stand up, go play.
Oh,
Okay, first of all, you'll get your question in the comments at the end. Afterwards, we'll have a committee meeting, and we'll keep talking, I guess, Apple and Sun. But before we get anywhere, that's not the actual slide. Here, just going to show you how to actually play with a server.